In this video, we're going to break down implicit differentiation. I'm not going to go into the ins and outs of how and why it works in particular. I want to try to make this easy. So first things first, why do we need it? So differentiation, right? We're finding a derivative. So far, all we have done is explicit differentiation. What that means is we had y as a function of x. Well, looking at number 7, if I try to solve for y, I'm always going to have some other y on the other side, right? Even if I subtracted that 2y to the third and try to factor, I cannot solve for y easily, that is. Okay, maybe it's obtainable, but sometimes it's too much work, and that's what I wrote over here in this rainbow color. Our old way, sometimes it's impossible, sometimes it's too much work, and sometimes it leads to multiple derivatives. Okay, and that, isn't necessarily a problem, but implicit differentiation is here, hopefully, to make things easier. So with that said, let's do these two examples. What I want to tell you is when you do derivatives, just simply do the derivative as you normally would. Okay. Now, anytime there's a y, though, we're going to include this dy dx. That's as simple as I could put it. The reasoning behind it, we could look into that later. So, what we're doing is we're doing the derivative with respect to x on both sides of this equal. Okay? With respect to x, right? The d means derivative with respect to x. Well, 2x to the third, there's nothing different than what we've done in the past. It's derivative with respect to x, there's an x. However, this is a y. So to take the derivative with respect to x, right, the variables don't even match. So again, the shortcut, derivative of y, think of it just as an x, right? It would just be 1. But anytime you have variables that don't match, I'm doing with respect to x, this is a y, you write dy dx. Okay. Same thing on the right. Derivative of 2y to the third is 6y squared. But it's a y, we're doing it with respect to x, dy dx. Derivative of x is 1. Because we're trying to find the derivative of y with respect to x, as the problem states, I need to isolate these on one side, pretend it's like a new variable, z, right? Pretend it's a z and solve for z. So I'm going to go ahead and subtract this dy dx to the other side. And I'm going to subtract the 1. Okay, all in one step, I'd have 6x squared subtract 1, 6y squared dy dx, subtract 1 dy dx. Right? So now we factor this dy dx out, because it shows up in both of these. In the parentheses, write what we're left with, 6y squared minus 1. And divide that to the other side. And that is your answer. Your answer can have x's and y's contained in it. That's okay. Oftentimes they'll have us evaluated at a point, and we need to know x and y in order to finish solving this problem, if that's what it asked. But that is the derivative of that equation above, derivative of y with respect to x. All right, let's do one more example. If we had, x and x here, I would need product rule. Okay, I have, this is my function f. F prime would be 1. G would be the y plus 2 the fifth. G prime would be 5 y plus 2 to the fourth. Chain rule it. Well, derivative of the inner function is just 1, right? So I don't need it. However, this was a y. dy dx. Anytime you're doing derivative of a function y and I have with respect to x, we need dy dx. So now product rule. F prime g, so that's just 1 multiplied by y plus 2 to the 5th, plus fg prime, x multiplied by 5y plus 2 to the 4th, dy dx. And the derivative of the right-hand side is just a constant, is 0. Okay? Solve for dy dx. Right? We still have product rule and quotient rule even with implicit differentiation. Trick is, remember the dy dx if you're doing any derivative with respect to x. We'll look at some actually later where we'll do derivative with respect to t, let's say. Alright, solve for dy dx, so I'm going to subtract this guy on the other side. So we have 5x y plus 2 to the 4th dy dx equals a negative y plus 2. I'll give myself a little bit more room here, to the 5th. Divide that other stuff out, right? Get dy dx by itself. So we'd have negative y plus 2 to the 5th divided by 5x y plus 2 to the 4th. We can cancel 4 of these, right, since it is all multiplication here. And the final answer we're left with, derivative of y with respect to x is a negative y plus 2 to the 1, right, because we canceled 4, all over 5x.